Alright, so let's continue with our graphing of rational. So let's go ahead and do part C. So we're going to do exactly the same thing. Let's start off first with the holes. Okay. So when I factor this guy, you're going to get 6 on top, and on the bottom you're going to get an X and an X. This seems to be, what would this be? Not 3 and 2, so 6 and 1. And then I think this one should be negative and this one should be positive. I think that should work. So nothing cancels out, so there are no holes. So no holes here. Alright, so now let's look for our vertical asymptotes. So that's going to be when the denominator is equal to 0. So we're going to have x minus 6, x plus 1 equal to 0. So x equals 6 and x equals negative 1 will be our vertical asymptotes. Alright, now let's look for our horizontal asymptotes. So for horizontal, we can see that the degree of the numerator, which is 0, is less than the degree of the denominator. So when this happens, if the degree of the numerator is less than the degree of the denominator, there will be no horizontal asymptotes. Or, just kidding, y equals 0 is the horizontal asymptote. Alright. Now, because there was a horizontal asymptote, that means there's no slant asymptote. Alright. Now let's look for our x and our y intercepts. So our x-intercepts, remember our trick for this guy was to set the numerator equal to 0. So when I set the numerator, which is 6, equal to 0, well, that gives me nothing, which means that there's no x-intercept. So this guy is not going to cross the x-axis at all. And then the y-intercept, we're going to set the x is equal to 0. So we're going to get 6 over 0 squared minus 5 times 0 minus 6. So you're going to get 6 divided by negative 6, which is equal to negative 1. So this will cross the y-axis at 0, negative 1. Alright, so we got all of our criteria that we needed. And now all we really got to do is just go ahead and graph this guy. So we're going to start off by our vertical asymptotes, which is going to be negative 1. And now let's look at our other asymptote, which is 6. We have a horizontal asymptote at 0. Alright, so here it is. So here's my x equals negative 1, x equals 6, and y equals 0. Alright, and we know that this is going to cross the y-axis at 0, negative 1. So 0, negative 1, you're going to have something that looks like this. Alright, so again, you can already realize what the graph is going to look like. But we're going to go ahead and plug in some points. We know that it's not going to cross the x-axis at all. So if you want to see what exactly is happening on this side, let's plug in like a number like negative 2. So if you're unsure of where this is going to go. So when I plug in x equals negative 2 into our function, let me plug it in. So 6 over negative 2 squared minus 5 times negative 2 minus 6. So I'm going to go into my calculator and get 6 divided by negative 2 squared. So that's 4 plus 10 minus 6. That's going to give me about 3/4. So that's a positive. So that means that 3/4, which is about right here. So that means because we know that it's not going to go below it, it doesn't cross the x-axis, we can say that the top guy from this side is going to look something like this. So it's going to attach to it's going to hinge towards the asymptotes. Now, for this middle guy, you can plug several points. We know that it's not going to go upward. So we know, well, first, at x equals negative 1, we can see that this has a multiplicity of 1. It doesn't have any, it's a positive. It looks kind of like a graph of 1 over x. So we know that this is going to be attaching towards this way because they're all going to be opposites. One other thing that you can do is to plug negative 1/2, and you'll see that it's slightly right below it. Okay, and now what about the other side? So we can plug in another point. We know that this is not going to go up though, because if it did, that means we would have had an X-intercepts. So all this is going to look like is going to kind of trace this guy out. To kind of double check that it's actually going to be in the bottom, let's pick a point. Let's pick, like, I don't know, +2. Pick in +2. 6/2 squared minus 5 times 2 minus 6. And you put this in the calculator, 6 divided by 4 minus 10 minus 6. You'll see you'll get a -1/2. So this guy still stays on the bottom. All right, so you'll have this nice parabolic shape. Now after that, we want to see what's happening after 6. So we can plug in another point, x equals 7. So we'll have 6/7 squared minus 5 times 7 minus 6. So you'll have 6/7 squared minus 5 times 7 minus 6. And that'll give me a +3/4. So it's going to be up here. And that shouldn't be that that shouldn't be surprising, because if you see at x equals 6, x equals 6 also kind of has the same format. It also looks like 1/x. So you can see if this guy's going to be going downward, it will make sense for the other side to be going upward. Just like that. So this graph will look something like that. All right, and that's the graph right there. Again, you can always plug in more points to kind of make sure that you sketch it a little nicer, but all I'm really looking for is something like this. So again, you can plug in points, or you can just go ahead and look at the behavior of either 1/x or 1/x squared, so on and so forth. All right, so let's go ahead and do this next example. So let's say this guy, let's go ahead and start by factoring it out. So let's factor the top guy out, and let's factor the bottom guy, if we can. So here it looks like you're going to have a 5 and a 1. And then this should be negative, this should be positive. And on the bottom guy, you're going to have a 2 and a 1. This should be positive, and this should be negative. So right off the bat, you see that there's going to be a cancellation of x minus 1. So you have x plus 5 divided by x plus 2, which indicates that you're going to get a whole. So do you have a whole? The answer is yes, because you had a cancellation. And that's going to happen at x minus 1 equals 0, which is x equals 1. And again, to find the y value, you're going to plug it in to our new function. So we're going to look at this guy now, new function. We're going to plug in the 1 in there. So 1 plus 5 divided by 1 plus 2 will give me 6 divided by 3, which gives me 2. Okay, so that means this is my y value. So my whole will be at 1, 2. That will be where the whole is at. Okay. Now what we're going to look at is we're going to look at this function now. We're not going to look at this guy anymore. We don't care about this guy. It's imposter. So now we're going to look at the vertical asymptotes. Notice we still have a rational because we still have a ratio of two polynomials. So we're going to set the denominator equal to 0. So x plus 2 equal to 0. You get x equals -2. So we only have one vertical asymptote. Now let's take a look at the horizontal. In this point, you see that the degree of the numerator is equal to the degree of the denominator. So both the same. So that means it's going to be the ratio of the leading coefficients, which in this case will just be 1, y equals 1. And because we had a horizontal asymptote, that means that there's no slant asymptote. Okay, now let's look at our intercepts. So x-intercepts, we're going to use a trick again, letting the numerator equal 0. So that's x plus 5 equals 0. So x equals -5. So -5, 0 will be one of my x-intercepts. And then my y-intercept will be when x is equal to 0. So that will be 0 plus 5 over 0 plus 2. This gives me 5/2, or 2.5. So 2.5, 0 will be my y-intercept. Okay, so now let's go ahead and graph it. So we start off with my vertical asymptote at -2. So I'm going to draw this. We're going to also find my horizontal asymptote, that's at y equals 1. And then we're also going to have a couple intercepts. So x-intercept at -5, 0. So 3, 4, 5, comma 0. And then we have a y-intercept at 2.5. So this is 2, this is 3, so 2.5 is right here. And kind of already, you can kind of see where everything is at. Oh, don't forget about our hole. Our hole is at 1, 2. So 1, comma 2. So there's a hole here. So already you can kind of sketch it because we don't need to really plot points. We can see that this guy on this side to the left of x equals -2, you already see that there's a point already plotted there. So all we got to do is just kind of sketch it from there all the way down here. Okay, we know that it's not going to cross. This is going to be attaching to the intercepts. I'm sorry, to the asymptotes. And now this one, we already have points up here. So this one, we can just trace it out. Upward and then downward. And you can see that the multiplicity x plus 2 has the behavior of 1 over x. So you can see that both of these guys are going to go in opposite directions. So this guy will be our graph with our hole right there at 1, 2. All right. And now let's do this last example. Whoops. So again, this one, let's go ahead and factor. So x plus 2 divided by x minus 1. So it doesn't seem like anything cancels out, so there's going to be no holes here. Now let's look for vertical asymptotes. That will happen when the denominator is equal to 0, x minus 1 equals to 0. So we got x equals 1 as my vertical asymptote. Then let's look at the horizontal asymptotes. So if you take a look at the leading coefficients, the degree of the numerator is much greater than the degree of the denominator. So in this case, there's no horizontal asymptotes. So since there's no horizontal asymptotes, there might be a slant asymptote. And there actually is, because you can see that the degree of the numerator is 1 more than the degree of the denominator. You can see that this is 2, the degree of the numerator is a 2. 2 is 1 more than 1, which is the degree of the denominator. So we know that there's going to be a slant asymptote. So how do we find the slant asymptote? So what we got to do is long division or synthetic division. So I'm going to use synthetic division, but you can use long division as well. So let's look with the top guy. So that's going to be a 1, a 2, and a placeholder for the 0, because there's no constant. And remember that the bottom one, that minus 1, we're going to change the sign to a 1. So I'm going to bring down the 1. Gives me a 1, then a 3, 3, and then 3. So this is the remainder, which we really don't care about. All we really care about is this guy. So the slant asymptote will be at y equals x plus 3. Long division would also work as well. And now finally, let's look for our x-intercepts. So again, we're going to do the same thing, set our denominator, set the numerator equal to 0. So you have x squared plus 2x equals 0. You can factor out an x. So you get that x equals 0 and x equals -2 is going to be my x-intercept. So 0, 0 and -2, 0. These will be my two intercepts. And now when we look at my y-intercept, we'll get x equals 0. So you're going to get y equals 0 squared minus 2 times 0 over 0 minus 1. So I'm just plugging it back into the original. And this just gives me 0. So y-intercept will be 0, 0. Alright, now is the time to sketch. Alright, so let's start off by looking at my vertical asymptote, which is at 1. let's look at my slant asymptote, which is y equals x plus 3. So right now the y-intercept is 3. So that means that at the y value in the y-axis, you're going to go up to 3. 1, 2, 3. And then the slope is 1, so the rise is up 1 over 1. So my slant asymptote will look something like this. Okay. Now we know that my x-intercepts are 0, 0, and negative 2, 0. So negative 2 is probably around here, and 0, 0 is around here. So this tells me that my first hyperbola is going to attach to them, right? It's going to attach here, cross over to 0, and then look like this. So this guy is going to look something like that. And now for the other one, it's either going to look on the other side or right across from it. So these can be really tricky. So what you can do is you can plug in a number that's greater than 1. So let's plug in like 2. So I'm going to plug in x equals 2. So you're going to get y equals 2 squared plus 2 times 2 over 2 minus 1. So we got 4 plus 4 over 1, which gives me 8. So at 2, I'm going to go all the way up to 8. So somewhere around here. Oops. So that means that my slant asymptote is going to go somewhere here. This is definitely not drawn to scale. Oh gosh. Okay. Maybe I can put the 8 up here. So the graph will look something like this. Right? And that's going to be that graph. Okay, so these guys are kind of rotated in relation to in comparison to the other guys. So that's how you graph those rationals.